Welcome to this edition of the Designs for Health audio science article.
The muscles and bones in our body work together as a team. Efforts to preserve the health of one may also help protect the other. It is important to understand how muscles and bones interact to support musculoskeletal health as we age. During the aging process, sarcopenia, or age-related muscle loss, and osteoporosis, low bone mass, often develop side by side. When both diseases, sarcopenia and osteoporosis, are present, this is referred to as sarco-osteoporosis. Until recently, it was believed that the only interaction between muscle and bone was mechanical interaction. New evidence published in the journal Bone in 2019 indicates that muscles and bones are also linked by biochemical communication as crosstalk through the molecules they secrete. Muscle cells synthesize and release small messenger proteins called myokines, particularly when muscles contract during physical activity. Myokines can communicate with bone, muscle, and other tissues and organs. Some myokines support the formation and maintenance of the musculoskeletal system. One osteogenic myokine is called irisin, which promotes an increase in the mass and strength of cortical bone, making up 80% of the body skeleton. Insulin-like growth factor 1, or IGF-1, is also a myokine, which stimulates bone anabolism and promotes muscle growth. Another myokine, beta-amino isobutyric acid, may help prevent bone loss during immobilization. Beta-amino isobutyric acid helps maintain the bone cell's mitochondria and helps protect osteocytes from apoptosis induced by reactive oxygen species. However, osteocyte receptors for beta-amino isobutyric acid are significantly downregulated as we age. Bone cells also secrete biochemical messenger compounds, which are referred to as osteokines. One osteokine is prostaglandin E2. Preliminary in vitro research suggests prostaglandin E2 and other osteokines may induce the formation of muscle tissue. Scientists speculate that administering prostaglandin E2, irisin, and other molecules that participate in the bone-muscle crosstalk may have clinically relevant benefits for sarco-osteoporosis. More research is needed in this area. Fortunately, many nutritional factors support musculoskeletal health in addition to resistance exercise and other physical activity. Protein intake supports both muscle and bone health. A high protein intake was once thought to harm bone health. However, the current scientific consensus from Nutrition Today indicates that higher protein intake does not appear to adversely affect bones in generally healthy people, especially if calcium intake is adequate. Moreover, protein intake may support intestinal calcium absorption. Protein may also support IGF-1 production. Animal research has shown an increase in IGF-1 levels after supplementation with essential amino acids. Branched-chain amino acids, which include leucine, isoleucine, and valine, may be beneficial, especially for supporting muscle protein synthesis. To support bone and muscle health, a daily protein intake of 1.4 to 2.0 grams per kilogram of body weight is sufficient for most healthy, exercising older adults, according to the International Society of Sports Nutrition. Individuals who are malnourished or at risk of malnutrition due to acute or chronic illness may need additional protein. Some evidence suggests that at least 20 grams to 25 grams of high-quality protein per meal is required for appropriate stimulation of postprandial muscle protein synthesis over a 24-hour period. However, protein intake tends to be relatively low at breakfast, which may limit potential support for muscle health. A healthy diet helps supply the vitamins and minerals needed to support muscle and bone health. These nutrients include vitamins D and K, calcium, magnesium, and zinc. In addition, vitamin D synthesis can be triggered endogenously through sunlight exposure, and vitamin K can be produced by gastrointestinal bacteria. Many factors, such as poor dietary choices, limited sun exposure, and impaired intestinal health can lead to insufficient nutrients that support the musculoskeletal system. Optimizing the intake of certain vitamins and minerals may support musculoskeletal health and bone-muscle crosstalk in the following ways. Vitamin D. Numerous in vitro and in vivo studies have shown that vitamin D plays an important role in bone and muscle metabolism. Vitamin D also acts as a mediator in the crosstalk between muscle and bone by supporting several myokines and osteokines that may have beneficial effects on muscles and bones. Vitamin K. Vitamin K is important for regulating bone and cartilage mineralization. Preliminary observational research suggests that vitamin K may play a role in supporting muscle strength and physical performance. Calcium is a mineral that has long been known as an essential structural component of bones. Decorin, a myokine secreted by muscle fibers in response to muscle contraction and resistance exercise, promotes calcium deposition into bones. Magnesium. About half the magnesium in our body is found in our bones and teeth. This vital mineral regulates enzymes involved in calcium metabolism. Magnesium also serves as a cofactor for vitamin D biosynthesis, transport, and activation. Lastly, zinc. This trace element is essential for the growth, development, and maintenance of bones. Zinc also has antioxidant actions and is believed to have the potential to support muscle tissue during disuse when oxidative processes are taking place.
Thanks for listening. For more excellent educational content, be sure to visit designsforhealth.com.